Okay, Cappuccino, here's some further notes on solving systems with substitution. So some of you got to task number 4 in class, which was this problem. Sergio was given $100 for his birthday. He started spending at an average rate of $10 per day. Nicole only had $25, but she worked, earning an average of $5 per day, and didn't spend any of it. So some of you tried this problem in class, some of you didn't, but we're going to go ahead and work through it together now. So on day 0, that's how much money Sergio was starting with. He had $100. And each day he's spending money. So if he spends money, then his amount of money is going to go down. So it's going to go down $10 each day. So after one day, he's at 90, 80, 70, etc. So I can fill in how much money he has every day. So after 10 days, he has no money left. Nicole started with only $25, but she's saving money. She's saving $5 per day from her job. So she's adding $5 each day. So the next day she'd have 30, 35, 40, etc. So now we can look at this multiple ways. We've made a table. Now we're going to graph it. Then afterwards, we're going to make a set of equations. So if I graph this, I'm going to start out with Sergio. On day 0, he has $100, so 0, 100. Then on day 1, he has $90. Day 2, he has $80. And I'm just going to go down $10 each day. And then notice on day 10, he has no money left, which matches my table. So I'm going to pick a color for this. I'm going to put Sergio in green. Now I'm going to do Nicole's money. So on day 0, she has $25. After one day, she has 30. After a second day, 35. So notice hers isn't going up very steeply, but it is going up. And I can keep going all the way across. So on day 10, you can see she has 75, which matches my table. And I'm going to put hers in blue. Notice what happened right there. They ended up being at the same dot. So right there, they ended up being at the same dot. We call that the solution to the system. Where both lines are at the same place at the same time, we call that the solution. So this point right here is considered the solution to the system. And what's happening at this point is that on day 5, both Sergio and Nicole have $50. Notice we can see that same answer in our solution, in our table. So right here, notice that on day 5, both of them have $50. So I can see my solution on the graph. I can also see my solution in the table. The solution to this system, this is a problem that has 2 lines. We call that a system. The solution is where the 2 lines cross each other. Okay, so let's see if we can write an equation for Sergio and Nicole. So Sergio has a starting point of 100 and his rate of change is minus 10. So I can write Sergio's equation, his equation of his line, y equals, his rate of change is minus 10, we always put that with the x, plus his starting point. We can do the same thing for Nicole. Her starting point was 25, but her rate of change is 5. She's adding $5 each day, and her starting point is 25. So now I've written equations for both Sergio and Nicole. Now I'm going to use substitution to find this solution using algebra. So I've already found the solution. I know what it is. I know that it's at day 5. They both have $50. That's the solution to the system. But now I'm going to find that same answer using algebra. So notice, I know that y equals negative 10x plus 100. So this y over here can be replaced with negative 10x plus 100. Okay, and what does y represent? Let's just remind ourselves. Y represents the amount of money. X represents the number of days. So I'm looking for when do both Sergio and Nicole have the same y value. So I want their y's to be equal to each other. I want their y's to be equal to each other. I want this y to equal this y. So if this y equals this y, then I can replace the y over here with what this y is equal to. So I can take this and I can substitute it in to Nicole's equation. So I can write, instead of this y, I can write, well, what does y need to equal? It needs to equal the same as Sergio's y, which is negative 10x plus 100. Sergio's y is negative 10x plus 100. I want it to equal Nicole's y, which is the amount of money. I want it to be the same as Nicole's amount of money. And her amount of money is equal to 5x plus 25. Now I just need to solve this equation for x. So here's my equal sign. I like to put a line through it, because if I do something to one side of the equation, I have to do the same thing to the other side of the equation. I do not like negative numbers, so I want to get rid of that negative 10x. The opposite of a negative 10x is a plus 10x. So I'm going to add 10x to both sides of the equation. If I do something to one side, I have to do the same thing to the other. So negative 10x plus 10x is just 0, and I still have my 100. 5x plus 10x is 15x, and I still have my plus 25. 0 plus 100 is just 100. Now I need to solve this. I'm trying to get the x by itself. The x is being multiplied by 15 and added by 25. I think it'll be easiest to get rid of the plus 25 by doing the opposite, which is to minus 25. If I do it to one side of the equation, I have to do the exact same thing to the other side. So 100 minus 25 is 75. And on the right side, I'm left with 15x. So 15 times what equals 75? Well, the way to figure that out is to divide both sides by 15, because the opposite of multiplying, which I have here, the opposite is to divide. So I'm going to divide by 15 on both sides of the equation. And I get x is equal to, let's see, 5. I don't have my calculator handy, but 5 times 15, 5 times 5 is 25. Put down my 5, carry my 2. 5 times 1 is 5, plus 2 is 7. Yeah, that works. So 5, x is 5. And if I remind myself, that actually makes sense, because it was on day 5 that they have the same amount of money. And x is the number of days. So that makes sense. All is well. Okay, now when we're doing the algebra, we also have to solve for y. So now we need to solve for y. So I can take either one of these equations. I'll go ahead and take Nicole's because it doesn't have negatives. And I'm going to substitute in my number for x. So I said x was 5. So here where the x is, I'm going to change that to a 5. Because that's when I said they're going to have the same amount of money on day 5. So let's see how much money they have on day 5. 5 times 5 is 25. 25 plus 25 is 50. Aha, it matches my table and my graph. So we can write the solution as a coordinate pair. The x always goes first, and then the y. But we're also going to write it as a sentence. So on day 5, they both have $50. So what's important to notice about this problem is that we can solve it several ways. So we were given a word problem, And from the word problem, we made a table. And we could actually see on what day will they both have the same amount of money right there in the table. Notice the question wasn't given here. It was actually given farther down the page on task 4. So I probably should have written the question in here, which is on what day will they have the same amount of money? On what day will they have the same amount of money? That's actually the question. So I can see the answer in my table. I can see the answer where the lines cross each other on the graph, and I can find the answer using algebra and get the same answer. And then, since I was given a word problem, I want to give the answer in words. And there it is. I hope this helps.